The research paper A Towards Universal Representation for Unseen Action Recognition proposes a new method for unseen action recognition, UAR, which aims to recognize new action categories without training examples. The authors propose a pipeline that uses a large-scale training source to create a universal representation, UR, that can generalize to a more realistic cross-dataset UAR, CDUAR scenario. This is achieved by treating UAR as a generalized multiple instance learning, GMIL, problem and using distribution kernels to identify building blocks from the large-scale ActivityNet dataset. The UR can then be used to recognize unseen actions without further training. The authors' experiments showed significant improvements over the UCF 101 and HMDB 51 benchmarks. The authors first used deep neural networks to extract visual features, resulting in a GMIL problem. They then introduce a novel universal representation learning (URL) algorithm composed of non-negative matrix factorization (NMF) with a Jensen-Shannon divergence (JSD) constraint. This allows them to learn a part-based representation, which serves as the key basis between the visual and semantic modalities. The UR can then generalize to both visual and semantic views, and both source and target domains. The authors' main contributions include extending conventional UAR tasks to more realistic CDUAR scenarios, proposing a CDUAR pipeline, and developing a novel URL algorithm that unifies NMF with a JSD constraint. Their experiments showed that the UR can effectively generalize across different datasets and outperform state-of-the-art approaches in inductive UAR scenarios using either low-level or deep features. The research paper presents a study on cross-dataset unseen action recognition, CDE. UAR, a challenging problem in the field of human action recognition. The authors propose a pipeline that includes deep feature extraction, generative multiple instance learning, universal representation learning, and domain adaptation. They introduce a novel universal representation learning (URL) algorithm that incorporates non-negative matrix factorization with a Jensen-Shannon divergence constraint. The study shows that non-negative matrix factorization is advantageous for finding shared bases. The proposed method outperforms all other compared benchmarks in experiments conducted on the large-scale ActivityNet dataset and two widely used benchmarks, UCF 101 and HMDB 51. The results show that the proposed pipeline significantly improves performance in the CDUAR scenario.